Okay, so this week your assignment uses naive Bayes classification. Thought it would be good to talk a little bit about that algorithm. So a little background in comparison to other algorithms. There are three classification methodologies. The first is direct classification, where we directly classify an example based on our model and is what we generally do in neural networks, support vector machines, and linear regression models. The second set uses probability, like in what we saw with logistic regression, where we have a threshold on our sigmoid curve and thus tells us the probability of being in one class or the other. And finally, we have the probabilistic models within a class. Here we will talk about the naive Bayes model. To start, the naive Bayes model is built off of Bayes' theorem, which is presented here. And basically, it is the probability of C given X is equal to the probability of X given C times the probability of C divided by the probability of X. The results give us something called our posterior probabilities. So we have the likelihood of an example being classified times its previous probability divided by our new evidence that was found. So I'll explain. Our new evidence will come from our training set. We'll have our prior probabilities given before we tested our training set. It'll make a little bit more sense, hopefully, as I talk about it. So naive Bayes classification has been successfully used in many areas, such as spam classification in your email, medical diagnosis, and clinical decision support systems. So, based on a set of symptoms, what is the likelihood that a patient has a particular illness? It is also used in weather predictions, but meteorology tended to not be the best example because it's highly inaccurate. When we do Bayesian classification, we have our data with probabilities, and our goal is to predict some label for a new test example. So let's do an easy example on whether to play tennis or not. So we recorded some data for 2 weeks on whether we play tennis or not. We have 4 variables, and our output is whether we play tennis or not. We can then calculate the probabilities for each situation. We have 9 occurrences of playing tennis and 5 occurrences of not playing tennis. We can then find the probability of each variable on whether tennis was played or not. Since we have 9 days where we play tennis, we just count the occurrences of that particular variable. For example, for the outlook variable, there are 2 occurrences of being sunny where we also play tennis. Thus, the probability is 2 divided by 9. The rest of the probabilities are found the same way. So then we test the model on a new set of 4 variables. Our new test case is with an outlook that is sunny, temperature is cool, humidity is high, and the wind is strong. So then we go back to the previous slide and we look up our corresponding probabilities and plug them into our formula. We have the probability of yes given our test case. So we multiply the 4 probabilities together and get a probability of 0.0053. Then we do this for the probability of no given our test case. So we multiply those 4 probabilities together and we get a probability of 0.0206. So given that the probability of no was higher than the one for yes, that would be the output for the algorithm. So this is kind of a somewhat simplified version of what is going on, but hopefully it helps you understand the basic idea of a naive Bayes classifier. In an example of text classification, which is in natural language processing, we have our input, which is a document, and a fixed set of classes, and our output is a classified predicted case. This, we have to hand label our training set. So our naive Bayes model, we use something called the bag of words. So we want to reduce our document into a bag of easily classifiable connotation, or words with easy to understand connotation. So if we have this passage here, let's say it's an online review about a movie. Our first step is to identify the words that could help us classify the text to try to determine if it is positive or negative, or a positive or negative review. So we highlight the bolded words, and those are the words that we're in. So we then toss out all the other words into garbage and enumerate the words that we have. The classifier then calculates the probability of whether this was a positive or negative review based on So we send in a new document, we apply our algorithm that parses the words into what is recognized from the training set, and then it removes all the useless words and then generates what the likelihood of it being a particular class. So in this case, we send a new movie review through, and it will be able to determine if it is a positive review or a negative review. So the major advantages of the naive Bayes classification algorithm is it is generally very fast and does not take up much storage space. It is better than decision trees when you have many variables for splitting the decision. It is also a good, dependable algorithm for text mining and other NLP projects. But as we have talked about other algorithms like support vector machines, many other algorithms can outperform the naive Bayes model. It is important to keep the probabilities that the algorithm outputs because we can use those to determine the accuracy. So another advantage is we can use this model if we have a low amount of training data. Here we can see that even if we only had 30 training examples, we can still be about 86% accurate. Obviously, the more training examples we have, the more accurate we should get. But it is an advantage if you have a small data set. So the last thing I want to talk about is the difference between supervised and unsupervised models. Most of what we do in this class is supervised learning, where we have a training set of labeled data. We have seen this in our logistic regression, naive Bayes, support vector machines. Also, you'll see it in neural networks and random forests, which we'll talk about later. However, in unsupervised algorithms, we let the algorithm decide how to classify the data. This is where we will see clustering, which we will talk about in 2 weeks. As an example, let's say we have a set of Disney characters. We can use a clustering algorithm that will decide how to classify the characters. So here we can see that the algorithm separated the characters based on the kind of animal that they are. So we have a cluster of ducks, a cluster for Mickey Mouse, and then a cluster for rabbits for Bugs Bunny. And since we didn't have any training data, that's how the algorithm decided to categorize or classify that data. The last thing mentioned is another learning algorithm is called semi-supervised, which is basically the same as supervised, but we label a few of the training examples, and this is particularly useful when it is expensive or hard to get labeled training data.